One more time. With a price elasticity of demand less than 1, the denominator, which is the percentage change in price, dummy is larger than the percentage change in quantity demanded. So the downward pressure on price is larger than the upward pressure on the quantity demanded, which causes the total revenue really to go down. As opposite to that, if on the other hand your elasticity of demand is greater than 1, the percentage change in price decline is smaller than percentage change in quantity demanded, which means that the upward pressure upward pressure in the quantity demanded really dominates the downward pressure on the price, causing total revenue to go up. Finally, we could have a situation where your price elasticity of demand is just equal to 1, which means that the percentage change in price is equal to the percentage change in quantity demanded, which means that the downward pressure on price is exactly equal to the upward pressure in quantity demanded, which causes your total revenue to remain unchanged. Please take a moment to review this. And this is very important. I can assure you that these are going to be in your upcoming exam. So if you have any question, this is the right time to ask. Does it make sense? Are we all clear on the interpretation of the price elasticity of demand and how they affect total revenue? In summary, when you're trying to reduce price, if your demand is price inelastic, your total revenue is going to go down. If your price elasticity of demand is greater than 1 or elastic, your total revenue is going to go up. And if your price elasticity of demand is unit elastic, like equal to 1, it's not going to have any effect on your total revenue. That's the math. This is not a mathematical course. What we want to do now is we want to try to understand what are these cases telling us about the actual market. So let's start with the fact that your price elasticity of demand is less than 1. What kind of good are we talking about here? From our previous discussion, we have learned that the price elasticity of demand is smaller than 1, probably for goods such as like insulin. A life-saving medication, you really need that. You are price insensitive to a good like insulin because you really don't care about the price. You need the good anyway. So if the good that the firm is selling has an inelastic demand, should a firm cut the price on that good? What would our firm benefit by cutting price? The reason why firms cut price is because they want to attract new customers. Isn't that right? The reason why firms cut prices is because they expect consumers to respond to that by buying more. But if the good is inelastic, it means that consumers are already buying what they want to buy because they need that good. If firms cut price, they are not going to get any more customers because people who don't have diabetes are really not going to buy insulin only because the price of insulin have gone down. Make sense? So when the good is inelastic, it doesn't make any sense for our firm to cut price if they want to raise total revenue. If raising total revenue is the objective of our firm, it makes no sense for them to cut price if the good has an inelastic demand. What should a firm do if the demand is inelastic and the firm wants to raise total revenue? They should raise price rather than cut price, right? More on that later. Now, on the other hand, let's imagine the price elasticity of demand being greater than 1. What kind of good are we talking about here? What are these goods? Well, we have to be a little bit careful, but I will call them luxury goods. Because in a minute we are going to see that luxury good is a slightly different thing. Luxury good is actually related with your income. But these are goods which are probably very expensive. An expensive good doesn't really have to be luxury. So this is like economic stuff. That's not that important. Let's imagine a good that you really don't buy, like a luxury ship, cruise, or whatever, right? And whenever there is a cut in price, consumers buy a lot of those goods and total revenue goes up. So for those goods, which are like a luxury cruise ride, cutting price really makes sense for the firm. Because by cutting price, our firm can really raise their total revenue, something that they really care about. If the good demand is price elastic and firm wants to raise their total revenue, the only way a firm can do that is by cutting price. That will raise quantity demanded and revenue will go up. What we are looking at are realistic market interpretation of elasticity. And they are very important from an economics perspective. What we are going to do now is look at the same concept from a graphical perspective. The graph is equally fascinating, but I think the mathematical abstraction is more useful in the sense that sometimes you really don't have enough time to really draw a graph. There is a second reason why we are going to talk about the relationship between total revenue and elasticity from a graphical perspective, which is to show that within a same linear demand curve, you might have various measurement of elasticity. And I will talk about that in a minute. Imagine the graph that we are looking at. That and this is from previous experiments, that you are thinking about cutting price of the good from $4 to $3.70. If you do that, quantity demanded increases from 1,000 to 1,050. So your cutting price, your quantity demanded is increasing. So the question is, should you cut price? Should you cut price on your good by 30 cents? The answer is that it depends. It depends on whether I can really increase my total revenue by cutting this price. Let us try to understand how this cut in price is affecting the total revenue of our firm. Now, imagine that when you cut the price from $4 to $3.70, our firm is going to be losing 30 cents on every 1,000 units that they were selling before. When our firm is cutting the price from $4 to $3.70, our firm is going to lose 30 cents on every unit of 1,000 units that they were selling before. So 30 cents times the 1,000 unit, which is $300, is the loss of revenue from this price cut. So by cutting price, $300 is the revenue that our firm loses. But our firm also gains something, right? Because since they cut price, they are now able to sell more. They were able to sell 50 more units. Each of these 50 extra units are being sold for $3.70. Do we all see that? So this area really measures the extra revenue or the revenue gain by our firm, which is $3.70 times the extra 50 unit the firm is selling, which is going to come down to 185. This is the gain in revenue. So by cutting price from $4 to $3.70, our firm loses $300, gains $185 in revenue. Do our firm really gain at the end? It should be clear, if you just compare these two numbers, is that by cutting price, our firm loses more, $300, than gaining. Our firm gains 185, loses 300. Now, if you look at the numbers that are provided to you, the original price, the new price, the original quantity, the new quantity, you can calculate the elasticity of demand, and you will see that the absolute value is less than 1. We have done that in the previous class. So now let us connect the dots. We are really dealing with a demand curve for which the price elasticity of demand is less than 1. And we have just shown and convinced ourselves that whenever there is a price cut for a good for which demand is price inelastic, total revenue really goes down. But I want you guys to go beyond that and have a more refined interpretation of graphs. Understanding and interpreting graphs are very, very critical for the two chapters that we are covering. The one before and the one that we're covering right now. If you look at the graph, the demand curve, you'd realize that this is kind of inelastic, right? It's kind of steep. If you know that, you really don't need to go through all the stuff that we just went through. You know that if this is a good for which the demand is inelastic, cutting price is a bad idea. It's going to reduce total revenue. Once you move to the next graph, you should see immediately that this graph is much flatter than the demand curve that you looked at before. So this one is a demand curve for which the price elasticity of demand is probably greater than 1. And once you have a more flatter demand curve, you do the same calculations, you cut the price by the same amount from $4 to $3.70, you lose $300 as revenue by cutting this price, but now the demand is elastic, the price elastic. And it causes an increase in demand from 1,000 to 1,200. So by cutting price, you are now able to gain $3.70 times the extra 200 unit that you sell. If you do the calculation, it will turn out to be $740. And this is the gain in revenue. Now the calculation is fundamentally different. By cutting price from $4 to $3.70, you are losing $300 worth of revenue, you are gaining $740 worth of revenue. So it should be clear that by cutting price, you are raising your total revenue. Make sense? But you see that if you study well on this chapter and have a very good understanding about how does an elastic demand curve look like and how does an elastic demand curve look like, you don't need to do any of this calculation that we just went over. If you simply know that your demand curve is elastic, you know cutting price probably will raise total revenue. If you know that your demand curve is inelastic, you know cutting price is going to reduce your total revenue. So if you are the seller of insulin and you want to raise your total revenue, should you cut price or should you raise price? You should raise price because we have just shown that demand curve for insulin is price inelastic. It's a steeper demand curve, and the only way you can raise total revenue is by raising price. But if on the other hand, your good is a luxury cruise ride and you want to raise revenue, the only way you can do that is by cutting price on those goods. And when you look at this from a realistic market perspective, you see that that's exactly what happens in real world. In the last class we mentioned that the cost of our prescription drugs have quadrupled in the last 10 years. It's actually have gone up more than that. How is that even possible? How is that possible that in front of our eyes the cost and the price of our life-saving medications are rising? In no other country it does that, by the way. In no other countries, the price of prescription drugs have gone up this dramatically. And it makes perfect sense, right? If I know that the good that I'm selling in the market has a very inelastic demand, I'm going to raise the price to raise my revenue. And at the same time, you will see frequent price discounts on luxury goods such as cruise drive and all those things that are quite expensive. So what we have just covered has a very, very realistic market interpretation. Now, the next topic that I'm going to cover is slightly different in a sense that we have, after learning about what price elasticity means, what inelastic demand means, what inelastic demand means. We are now going to do a different kind of thought experiment. Before I tell you what the thought experiment is, we are going to carry out the experiment and then conclude and show you why this is such an interesting example. What you are looking at is a stereotypical artificial data on the market. You have some information about price, you have some information about quantity at those prices, and you are calculating the total revenue by multiplying the price and the quantity. The first two columns are information about a demand curve. At different prices, it is telling you how much output consumers are buying. Notice that when the price is very high, at $8, people are not buying anything. As price goes down, quantity demanded increases. When price was very high, quantity demanded was 0, total revenue was 0. Do you all see that? When the price is 0, people are buying a lot, but then again, total revenue is 0. Right? Between a very high price and a very low price, we are now looking at some numbers, some prices, and the way total revenue is affected by these two prices are fascinating. Let's start from the top. When the price goes down from 8 to 7, notice quantity demanded increases from 0 to 2. Total revenue increases to $14. That's the total revenue. Price goes down from 7 to 6. Total revenue increases from 14 to 24. A major jump, right? 6 to 5, total revenue increases from 24 to 30. From 4 to 5, total revenue increases from 30 to 32. When price falls from 3 to 4 to 3, total revenue goes down. Do you see that? And then when price goes down from 3 to 2, total revenue again goes down. When the price goes from 2 to 1, total revenue again goes down. So what we are seeing are fascinating interpretation of total revenue and elasticity. We see that total revenue appears to have a dome-shaped curve. It increases first, reaches a maximum, and then goes down. The price at which total revenue is maximum is 4. Do we all see that? Why is that? Why is this happening? We know that the experiment that we just carried out is where prices were going down all the time. But the revenue were responding differently depending on what prices we were considering. You can see clearly that in the upper region from price of between 4 and 7, when the prices were going down, total revenue was going up. Do you all see that? When prices were going down, total revenue were going up. Do we all see that? What we have just covered so far, based on our understanding, we know that at these prices, elasticity of demand is greater than 1. Isn't that right? Then again, there is a second part where between the price of 4 to, let's say, 1, elasticity of demand is smaller than 1, because in this range, as prices were going down, total revenue was also going down. So we are now looking at two different price regions. In one region, demand is elastic. In the other region, demand is inelastic. But we are on the same demand curve. That is fascinating. Even within a single demand curve, we have just identified a region that is elastic, and we have identified a region that is inelastic. When we put these numbers in a graphical setup, we will see first that the upper figure is just plotting the first two columns in your data, price and quantity demanded. As you can see, it's a downward sloping straight demand curve. You know that the slope is constant here, right? The slope of this demand curve is constant. It's a straightforward downward sloping straight line. But elasticity is not constant. Elasticity changes. So this is the direct proof that slope and elasticity are not the same thing. They give you same interpretation, but slope is constant in this case, elasticity is not. How is it not? Because we see clearly that when the demand was elastic, between the price of 7 to 4, cutting prices were really raising your total revenue. Do we all see that? Cutting prices in the upper panel were increasing your total revenue. So it means that in this case elasticity of demand was greater than 1. In the lower region, from 4 to 1, when we were cutting prices, your total revenue were going down. So in this region, elasticity of demand is smaller than 1. This is called inelastic demand. And between the elastic demand and inelastic demand, we have a point where elasticity of demand is just 1, meaning that it is unit elastic. Unit elasticity is a theoretical concept. It has no practical interpretation. What is important is to understand that within the same linear demand curve with the same slope, the elasticity in the upper part of the demand curve is elastic. The elasticity in the lower part of the demand curve is inelastic. Any question? Well, that sort of concludes our discussion about price elasticity of demand. We are now going to look at 2 more measurements of elasticity related to the demand curve. Both of them are extremely important. They are all going to be in your exam. So we're going to come back to our Word document, and hopefully I'll be able to navigate and get out of this page, and I think I cannot, and I don't know why. Oh yeah, I can. Okay. So the next concept that we are going to look at is, so the second concept that we're going to look at about price elasticity of demand is called cross price elasticity of demand. And I'm going to use some notation that is instructive, so I'm going to use the same epsilon to indicate my cross price elasticity. But now I'm going to use these 2 notations, A and B, where my price elasticity of demand is going to be percentage change in quantity demanded for good A divided by percentage change in price for good B. So what we're doing here is we're looking at 2 goods, A and B. We are changing the price of good B, and we are looking at how the quantity demanded for A responds to those price changes. Please bear in mind, this is a completely different measurement of elasticity. In the other price elasticity of demand, we were looking at the change in price and the change in quantity demanded of the same good. Here, we are looking at 2 goods. We are changing the price of one good, and we are looking at the change in quantity demanded of the other. Are we all clear on that? Now the question that we are going to look at is how these 2 goods are related. Before we do that, the price elasticity of demand was always negative, hence the sign was irrelevant. In this case, the sign is very, very important, because the sign can be positive or it can be negative. Let's imagine that the sign is negative. So how can the price elasticity of demand be a negative number? Well, it can be a negative number if the sign on the denominator and the numerator are of opposite direction. Let's start with the situation when this is positive, as I think that makes more sense. So this number can be positive when the denominator is negative and the numerator is also negative, right? Let's consider that first. So this is A. So this means that when the price of B goes down, my quantity demanded for A goes up, goes down as well, right? Are we all clear on that? Does it mean this? So the sign can be positive when PB goes down negative, QD goes down negative. Both of them are going down at the same time. What kind of goods are A and B?
Substitutes.
Why?
Because if there's a price cut on
B,
then people will buy less of A because they can get more of B.
right. One should never forget that intermediary step. That's the critical one, right? So when price on B goes down, according to law of demand, people are going to buy more of B, right? We all know that. What is interesting here is that when people are buying B more, they are buying less of A. So what are these two goods? These are obviously Coke and Pepsi, right? We all see that. That when the price of Pepsi goes down, I buy more Pepsi, but a lot of people move away from Coke as well. So Coke and Pepsi are the example of A and B in this case, and hence they are substitutes. It is extremely important that we understand this. So if you have any question, please ask me. I just forgot one thing. I want to mention this before I move on. There is a table here. We just summarized what we have just covered from the price elasticity of demand. It talks about, what happens when the price demand is elastic, what happens when demand is inelastic, and so on. So if you can memorize this table, you are going to get at least one of the questions in the exam correct. Your exam has 25 questions. One question is worth like 10 points. So there should be a lot of incentive for you to memorize this table. Okay, move back. So when the sign is positive, these two goods are substitutes. For B case, when the price of B goes up, your quantity demanded for A goes up as well. This is the second way in which the sign can be positive. If the price of B goes up, you buy less of B and you buy more of A. That's what it means, right? When the price of B goes up, you buy less of B, you buy more of A. So A and B are substitutes. This can also be a negative sign. The cross price elasticity of demand can also be negative. The only way cross price elasticity of demand can be negative is if these two have opposite signs, right? Are we all clear on that? Meaning that when price goes up, quantity demanded goes down, or when price goes down, quantity demanded goes up. Right? Let's imagine the first one. Let's imagine that we are increasing the price and quantity demanded for A is going down. Okay? So price of B is going up, my quantity demanded for A is going down. What kind of goods are A and B? Price of B is going up, quantity demanded for A is going down. What kind of goods are A and B? So we can think about B as your sugar. Sugar is actually not a good idea. Let's call it coffee. So if B is your coffee and the price of coffee goes up, your demand for coffee goes down. If your demand for coffee goes down, your demand for sugar goes down as well, right? So if sugar is your good A, B and A are complementary goods. Make sense? Does it make sense? So in summary, your cross price elasticity of demand can be positive or negative. If your cross price elasticity of demand is a positive number, the goods are in question are substitutes. If the cross price elasticity of demand is negative, these goods are complements. The next one that we're going to look at is our next measurement of the price elasticity of demand, and I don't think I know how to go on the next page. So let's just open another one, but it should be a continuation of your existing page. Number 3 should be called income elasticity of demand. We usually write it as EI. Epsilon I. Epsilon is always the measurement of elasticity. I stands for income. I stands for income. Where we measure it as follows. We first calculate the percentage change in quantity demanded. we measure the percentage change in income, we take the ratio, and that's my price elasticity of demand. So in this measurement, we are trying to figure out what happens to quantity demanded when my income changes. Okay? Any question?
The top is quantity dependent.
Yes, always. Notice that the three measurements that we have just covered, all of them have quantity demanded in the numerator, right? The only thing that changes are the denominator items. In the price elasticity of demand is the price. In the cost price elasticity of demand is the price of the other good. In the income elasticity of demand is the income. Just like the cross price elasticity of demand, this number can also be positive or negative. Let's first look at a situation where this number is a positive number. How can we have a positive price elasticity of demand? We can have it when both of them have the same sign. Right? When income goes down, your quantity demanded goes down. When income goes up, your quantity demanded goes up. Let's imagine the first one. So when my income goes down, my quantity demanded goes down. That could mean that the income elasticity of demand is positive. What kind of good is this? When income goes down and my quantity demanded goes down, what kind of good is this? This is a normal good. A normal good is a good for which as your income increases, you buy more of that good. As your income goes down, you buy less of that good. So one way you can have a positive income elasticity of demand is when income goes down, quantity demanded goes down. And it can also happen as when your income increases, your quantity demanded also increases. That also could mean that this is a normal good. Right? Yes, you have a question.
Okay.
So when the sign is positive, goods are normal. What happens when the sign is negative? When the sign is negative, we know that the only way the sign can be negative is when the denominator and the numerator has opposite sign. Meaning that when there is an increase in income, the change in quantity demanded is negative, or when there is a decrease in income, the change in quantity demanded is positive. In the class, we have covered the first one. Let's imagine that your income increases and your quantity demanded goes down. What kind of good is this? So when the income goes up and I buy less ramen noodle, my ramen noodle is a inferior good. Now, when income goes down and I buy more of that good, that also is an inferior good. We really didn't talk about that, but we talked about Black Death. Does anyone remember Black Death? Or potato? I probably didn't cover it in the class. The basic idea behind inferior good came from the Black Death experience. Black Death is a period in European history where 70% of the European population died. That's a staggering number, by the way. Although Europe didn't actually have that many people at that time, but still 70% people dying means a lot, right? What happened was that during that time, the entire agricultural food production in Europe was destroyed because there were no farmers to farm. And people needed carbohydrate. The only available carbohydrate source was potato. So as people were becoming poorer as a result of this major economic shock, people were buying more potatoes. So potato was the first ever historically recorded example of an inferior good. Okay? We can also do a little bit of interpretation on the situation when we have a normal good, because we can have situation where our income elasticity of demand is positive and greater than 1. What kind of good are we talking about here? Our income elasticity of demand is greater than 1 and positive. Meaning when my income increases, my quantity demanded rises dramatically for that good. What kind of good is that? That, according to our economics course, is a luxury good. That, according to our economics course, is a luxury good. And when my income increases, but my quantity demanded increases, but the change is smaller, meaning that the income elasticity of demand is less than 1, we will call that a necessary good. Thank you very much. Does anyone have any question? I already covered about the exam. So I will meet you guys on Friday. On Friday, we are going to start the next chapter after covering the last elasticity concept, which is the concept on supply.